have my t to be equals to 2 is common to this. I can bring t and I can bring the 2 out. So I have 2 will be left with minus u plus or minus square root of u squared plus 2as over 2a. Then this a can cancel this, these 2 can cancel this 2, then I will be left with t equals to, I have 1 over a, don't let me write it this way, let me write it this way, minus u plus or minus square root of u squared plus 2as over a. Then here can I have my, this is the final answer, this is the answer. So you check your option, you can see that your a, 1 over a is shifted to the other side. So that means I can just say that 1 over a into, and this 1 over a is, I have minus u plus or minus square root of u squared plus 2as. And I will go to my option and see the one that will fit in. I have 1 over a minus u plus or minus u squared plus 2as. So option D will definitely be the answer. Now to question 4. Make x the subject of the relation. So we have 1 plus ax over 1 minus ax equals to b over q. So in this situation, the question asks us to make x the subject of the formula. Look at x in the numerator and also in the denominator. So what we need to do is to cross multiply. So let's cross multiply what we have. So we have q into 1 plus ax, then we'll have b into 1 minus ax. That's the first step. Then the next thing is to open the bracket. This times this q plus this times this, that will be aqx equals to p times this p minus p times this, that's apx minus apx. Now our x is here, but it's carrying minus here. So let's transfer this one to this side. That is the common sense there. Transfer, where you're having minus, transfer to the other side. You have aqx, and this one comes here, plus apx equals to p, and this one comes here, minus q. Then I can write this one as apx plus aqx equals to p minus q. So what is common here? X, and we are looking for x. We want to make x, so we just write x, which will now be left with ap plus aq equals to p minus q. Then what do we do next? We divide both sides by the barrier in front of x. And what's the barrier in front of x now? It's ap plus aq. So we have x into ap plus aq, which is equals to p minus q over ap plus aq. So this one too, ap plus aq. So this one can cancel this one. Then I will have x to be equals to p minus q over ap plus aq. So which is the same thing as saying x equals to, a is common here, so p minus q into a plus p. So go to your option and check the one that correlates to that. So by checking this, I have x to be equals to p minus q into p plus q. So automatically the answer here will be p. So the answer is p. Then the next question, question number 5. If bq equals to a raised to power minus 2 and c raised to power 1 over 3 equals to a raised to power half b, express c in terms of a. So that the question also express c in terms of a. So we have to look at the information closely. That's question 5. So that one is saying that b raised to power 3 equals to a raised to power minus 2. And the question now says that raised to power 1 over 3 equals to a raised to power 1 over 2 b. The question asks us to express c in terms of a. So the first thing we have to do here is to look for an expression, just like this is the first stage and this is the second stage. We look for an expression for for b in terms of a here. Since we know that we have b raised to power 3 equals to a raised to power minus 2, what do we need to do to find this one? B here is b raised to power 1. So we have to restructure this one such that it will be b raised to power 1. What do we need to do to this to get it in b raised to power 1? So what we can only do is to multiply the index, multiply both indexes by indices by 1 over 3, so that we have b raised to power 3 times 1 over 3 equals to a raised to power minus 2 times 1 over 3. That's what I'm trying to say. So this one comes with this. I have a b1, which is same as b. Then this one will be a raised to power minus 2 over 3. So I've been able to express b. I've expressed b to a now in such a way that b is now equals to a raised to power minus 2 over 3. Then anywhere I see b, I will replace it with this. Then I have c raised to power 1 over 3 equals to a raised to power half b. So what's our b? So b now becomes c raised to power 1 over 3 equals to a raised to power half. What's my b now? Times a raised to power minus 2 over 3. Remember, law of indices. When you have the same base multiplication and you add the power. So in that situation, I can have my c raised to power 1 over 3 equals to, this one will be a 1 over 2 plus minus 2 over 3. Minus times plus, that is minus. So I have a raised to power half minus 2 over 3. So I look for the LCM of this. What's the LCM? 6. How many 2 will I see in 6? 3. 3 times 1, 3. Minus, how many 3 will I see in 6? 2. 2 times 2, 4. So I have a 3 minus 4 minus 1 over 6. So I have c raised to power 1 over 3. And since the question asks me to express c in terms of a, that means I will look for a to make this one c. And if I want to make it c, I have 1 over 3. So what do I do to 1 over 3 to make it 1? Just multiply by 3. So I multiply this power of this by 3, multiply the power of this by 3. What am I saying? C raised to power 1 over 3 times 3 equals to a raised to power minus 1 over 6 times 3. So this 3 can cancel this. Then I have my c equals to 3a1, 3a2. So I have my a raised to power minus half. Therefore, my c equals to a raised to power minus half. So I go to my option and look for the one that correlates with that. So it will definitely be option A. Now, question 6. So you have made A the subject of the formula. So I have x plus A over x minus A equals to n over 1. So I make everything fraction, and I have to make A the subject formula. So what I need to do here is to cross multiply. Cross multiply 1 times x plus A, x plus A. Then I have n into x minus A. Then I open this one. I have x plus A equals to mx minus am. Then what letter is of interest? That is A. So you have the A here, you also have it here. So what I need to do is to transfer this onto this side. I have A plus am equals to mx minus x. So I have what is common here? A is common. 1 plus m equals to what is common here? X is common. M minus 1. So since I'm looking for A, I will divide both sides by 1 plus m. So A into 1 plus m divided by 1 plus m. Also x into m minus 1 divided by 1 plus m. So this one comes with this. Then my A will now be equals to x into m minus 1 over m plus 1. So that means my answer will now be a equals to x into n minus 1 over n plus 1. So that's the answer for this particular one. Then the last one under this is if gt squared minus k minus w equals to 0, make g the subject of the formula. So I have gt squared minus k minus w equals to 0. Make g the subject formula. So this is, I have to protect this. That means I need to transfer this on the other side. Gt squared equals to 0 plus k plus w. Then that becomes gt squared equals to 0 plus k plus w. That's k plus w. So I'm looking for my, and I want to make my g the subject formula. So I will divide both sides by what? T squared. So I have gt squared divided by t squared equals to k plus w divided by t squared. And this one cancels this. Then I have my g to equals to k plus w t squared. So I go to my option and look for the one that correlates to that. Then that will definitely be option A. So my answer will be option A. Now, let's consider some other subtopics such as the remainder theorem and the factor theorem. Apply remainder and factor theorem to factorize a given expression. Candidates should be able to fashion out this. Now, let's talk about remainders theorem. So, remainders theorem is saying that if a polynomial f of x, if a polynomial f of x is given such that the degree is greater than or equals to 1, and such a polynomial is divided by ax plus b, then the remainder will be equals to f into minus b over a. What are we saying? That means what it is saying is that if a polynomial f of x of degree greater than or equals to 1 is divided by this, then the remainder will definitely be equals to f function of minus b over a. That means this can only be calculated when you equate the divisor to 0. Then you have ax equals to minus b. And when you now make x the subject of the formula, you have minus b over a. That means the function of that x is the same thing as the function of minus b over a, which is equal to the remainder. So this is what the remainder theorem is saying. Also, let's see example to justify this remainder theorem. Let's look at this example. Find the remainders when this is divided by a 2 minus x, b 2x plus 1. If you have not solved any question under this particular type of polynomial, this is an opportunity. So what, according to the question, asks us to find the remainder. So we are given the f of x to be equals to what? 2x cubed plus 6x minus 8. Then they will definitely give you the divisor. So the first one is 2 minus x. Then the second one is 2x plus 1. Take note of that. This is the way the questions will appear in your UTME. So if you are given a function of x like this, and the question asks you to determine the remainder, according to Remainder theorem, this says that f of minus